All right, so today we are going to be working on 4-5. So you're going to need to have that 4-5 yellow note sheet out. We're going to continue trying to figure out what the roots of a quadratic are. So you're looking for those x-intercepts. Today we're going to be looking at using some algebra methods of being able to find those x-intercepts. So where does that parabola intersect the x-axis at? So let's use one of these using square roots here, since there's not a middle term here. So in other words, remember your form here is ax squared plus bx plus c equals 0. It probably has an a term in here where you got an ax squared. It could have a constant in here, but it does not have that bx term there. So what you're going to do here is you're going to bring the constants all over on one side when you don't have a b term like this. So I can subtract 10 to both sides here, get the 4x squared all by itself, divide by 4, x squared ends up equaling 9. Now I got to take the square root of both sides. When I take the square root of 9 there, I end up getting x equals 3, but remember it's plus or minus. Because if you put back in this original problem back up here, let me just show you how that would work. If I put a 3 up there for x squared, it'd be 3 squared is 9 times 4 is 36 plus 10 is 46. Or, and for that x squared up there, I could go ahead and put negative 3. So negative 3 squared is 9 times 4 is 36 plus 10 is 46. So both of those answers will work, 3 and negative 3. So let's do another one like this. And again, you can notice it's different because it doesn't have that bx term in down here in letter B there. So no bx term there. So what I'm going to do is I'm going to get the x squared term all by itself. So I'm going to bring 5 on over. I get 3x squared equals 30. Solving for x squared and getting all by itself, I get x squared equals 10. And now I need to go ahead and just get an x equals. So to do that, I have to take the square root to undo a square root, to undo a squared. We take the square root of both sides. So I end up getting x equals plus or minus the square root of 10. So solve that one. Sometimes they don't come out as nicely. I believe we've got a third one on there. So we've got 7x squared minus 10 equals 25. So no different. It doesn't have that bx term in there. There's no middle term in this. So just have a squared, and then you got your 7x squared there, and then you've got your constants there. So let's bring the constants on the right-hand side there together by adding 10. So we get 7x squared equals 35. Still solving for x squared, so now I can divide both sides by 7, and I get x squared equals 5. Again, trying to solve now for x, so I have to take the square root of both sides. So I end up getting x equals plus or minus the square root of 5. And I'm going to leave it like that. I'm not going to actually find the square root of 5. I'm going to leave my answer as exact answer rather than, if you actually did the square root of 5 on your calculator, you're going to get some decimal answer there. So that shows us now how to solve the equations of finding square roots when you don't have that bx terms. So let me show you another type of equation here. Now we're going to solve this. Now notice this one does have an ax squared plus a bx plus c, but it's not equal to 0 yet. These are some kind of special situations here. So, and I can tell right away, I'm looking over here at the 25, and I can easily find the square root of that. And if I can factor this left-hand side here, and I have exactly the same term in there twice, then I know this is one of those special situations that I can take the square root of both sides. So what I'm going to do is I'm going to go ahead and see if I can factor this side here, x times x. What times what gives me 4, multiplies to give me 4, and adds to give me 4. Multiplies to give me 4, and adds to give me 4. So that would be 2 and 2. So really, because I've got an x plus 2 twice over here, I can write that as x plus 2 squared equals 25. So now it's kind of like the square root problem on the other side that we just did. So to undo this squared term, what do? We can take the square root of both sides. Right? So now that I've done that, if you take the square root of a squared term, you just get what's underneath the square root, which is x plus 2. And then I could take the square root of 25 there, and I get 5. So don't forget I've got plus or minus 5 over on that side. So if you want, you can separate them. You can say x plus 2 equals 5, x plus 2 equals negative 5, and simply solve for x in each case. So minus 2, I'll get x equals 3. Other one here, minus 2, x equals negative 7. So those are two solutions that I got there for solving that equation. When you got a special situation where it factors and you get exactly the same term there being multiplied by exactly the same term there in parentheses, and then the right hand side is a nice square root as well. Really doesn't have to be a nice square root on the right hand side, but it sure looks a lot nicer. All right, so let's go down there to part B. Part B there, as we're looking at that one, I'm thinking, I wonder if I could factor this one. The other one up there factored so nicely. X times x is x squared. Two numbers that multiply to give me 49 and add to give me 14. Oh yeah, minus 7 and a minus 7 will multiply to give me a 49 and add to give me a negative 14. So I've got x minus 7 in here twice. And now to undo that squared, I can go ahead and do exactly what I've been doing all the way around here now. I can take the square root of both sides. So when I take a square root there of the left-hand side there, I end up getting x minus 7. And of the right-hand side there, I get plus or minus 5. Whoops, better put that equals in there. And now I'm going to separate that. I'm going to say x minus 7 because I've got two solutions equals 5. And we got x minus 7 equals negative 5. So let's solve those. I got to get x all by itself. Add 7. X equals 12. And add 7. X equals 2. So there's my two solutions there for part B there. And I don't know if there's another one like that or not yet. Oh, so now we're going into the completing the square here. Steps for completing the square. They're also written on your note sheet at the very top. To rewrite it, you want to put it in this form of x squared plus bx equals c. So you're going to bring your c term on the other side. If there's an a term, we're going to divide everything in there by whatever that x term is. So, or whatever the a x squared, whatever the a value from the x squared there is. We're going to pretty much try to keep these pretty basic though, and I don't think we're going to look at anywhere you've got an a term here. But basically to complete the square, we're going to add b divided by 2 squared to each side of the equation. We're going to factor it, we're going to find the square roots, and we're going to solve for x. So let me walk through one of these. So we don't have anything in front of the a besides a 1 there. So to be able to complete the square on these, we're going to add b divided by 2 squared to both sides because we don't have a c term in here, if you remember. It goes ax squared plus bx plus c equals 0, and there's no constant in here. So my b value is right here. Since there's no c term, that was the first step there. I'm going to add b, which is negative 10, divided by 2, and I'm going to square it and add to both sides. So I'm going to do that on the other side as well. I'm going to take b divided by 2 and square it. So really, negative 10 divided by 2 there is negative 5, and squared it, I get 25. So really, I'm adding 25 to both sides. So now, the next step here is to go ahead and factor that left-hand side there. What times what gives me x squared? What times what gives me 25? It adds to give me my middle term there of negative 10. And that would be a minus 5 and a minus 5. So since there's two x minus 5s, I'm going to write this as x minus 5 squared. And now we're back to doing what we did before on the last problems here. We're going to take the square root of both sides here. So we end up getting on the left-hand side x minus 5. And on the right-hand side, we get plus or minus 5. So now I'm going to pull these apart. I'm going to say x minus 5 equals 5 and x minus 5 equals negative 5. And I'm going to solve for x. I get x equals 10. My other one here, x equals 0. So there's my two solutions this time. Now part B there, again, using completing the square. So the first step is always, if you've got a C term here, which we do, we got a minus 3 here. We got to go ahead and bring that on their side, so I got to add 3 to both sides. So x squared plus 6x equals 3. And then I left some space in there because I'm going to add b divided by 2 squared to both sides. That's kind of the key to this one here. To complete the square, you want to add b divided by 2 squared to both sides. So my b value is just the 6 here. So I'm going to take the 6, divide by 2, and square it and add to both sides. I can do this. It keeps the equation here balanced. I haven't changed the value of the equation. I've just added the same thing to both sides of the equation, which is fine. You can do that. So now I'm going to clean this up. 6 divided by 2 is 3. And if I square it, I get 9. And same thing on the right-hand side. I'm going to factor the left-hand side. X times x is x squared. What times what gives me 9 and adds to give me 6? Oh yeah, 3 times 3 is 9, and 3 plus 3 is 6. So now I've got two x plus 3's there on the left-hand side, so I'm going to write that as x plus 3 squared equals 12. I'm going to undo my square root there by taking the square root of both sides. When I do that, I end up getting x plus 3 equals plus or minus the square root of 12. This time the right-hand side is not going to come out as nicely here, which is fine. That'll happen. And we can continue working with that one as well. So I'm going to keep working with that one. I'm going to bring my minus 3 on over. So I'm going to be an x equals negative 3 plus or minus the square root of 12. And if you're really, really good at this, you could break this down as well. I could break down that square root of 12. The square root of 12 is the square root of 4 times the square root of 3. And the square root of 4 I can find, it's 2, but I cannot find the square root of 3, so I'm going to leave that as the square root of 3. So there we have that solved.